This lesson in Engineering Science and 4, we are looking at dynamics. The question we'll be focusing on today is from the February 2022 past exam paper, and the question deals with calculating power of an object moving on a horizontal plane. The question reads as follows. An engine with a mass of 85 kilograms is pulled at a constant velocity. Now this is a very important term. It is pulled at a constant velocity of 1.8 meters per second along a horizontal surface, and it has a coefficient of friction of 0.5. Calculate the power required to pull the engine. So let's look at the given information. So number one, I have an engine. It has a mass of 85 kilograms. I'm going to tick because I find that mass is in the correct SI unit, kilograms. The most important term here is constant velocity. So when the velocity is constant, that means there is no change in the velocity. The velocity remains the same. So since the velocity remains the same, that means the object is not accelerating. Because remember, in order for an object to accelerate, you need to have a change in speed. Acceleration is the rate of change of velocity. So that means the symbol which we use for constant velocity is v, and my velocity is going to be 1.8 meters per second. As I've just explained, since there is no change in velocity, acceleration is going to be 0. It is very important to know whether the object is moving on a horizontal plane or an inclined plane. In this case, it's moving on a horizontal plane, and this is the symbol which I use for coefficient of friction, which is mu. It is equal to 0.5. So if I check velocity is in the correct SI unit, it is in meters per second. Once we are done with listing the given information, it is very important for us in dynamics to draw a diagram. So this here represents my horizontal plane. I have the object. It has a mass of 85 kilograms. The applied force is pulling it forward. Now remember, in order for an object to stay in balance in equilibrium, since there's an applied force acting on one side, for this object to be moving at a constant velocity, that means the forces in the system are in equilibrium, simply meaning that there are more than one forces acting on the system, keeping the object in balance. So the other force that's going to be acting on the object to keep it in balance in the opposite direction is going to be the force of friction. So if I now look at this, we said the applied force is moving it forward, friction moves it in the opposite direction. But what about the mass? When there is a mass, we also know that the force of gravity is acting on the object, so we are able to calculate the weight. The weight is equal to mass times gravity. Since there is a vertical force acting downwards, for this object to still remain in equilibrium and move at a constant velocity, for it to remain in balance and move in constant velocity, there must be a vertical force going upwards. And that vertical force is known as my normal reaction force. So this diagram now shows me all the forces acting on the system are in balance, helping the object to move at a constant velocity. We want to calculate the power. When an object is moving at a constant velocity, the formula which we can use for power is applied force times velocity. According to the question given, we do not have the applied force, which means we first need to calculate the force applied pulling the mass. So we're going to use the Newton's law formula on a horizontal plane for when it should have been accelerating, and that formula is accelerating force is applied force minus the frictional force. Please make sure you learn this equation of formula, as it is not on your formula page for the exam. Okay. If we look according to my question, we are not given this force here, which is the force of friction, which means I now have to calculate this force of friction. So if we now go to the formula page, we should find this formula here on your formula page, which says the coefficient of friction can be calculated as coefficient of friction is the frictional force divided by the normal reaction force. If I make this the subject of the formula, the frictional force is then going to be the coefficient multiplied to the normal reaction force, which is NR. Okay. If we look at my diagram now, we are missing the normal reaction force. So how do we find this force? Remember, we said at the beginning that the object is in balance. It's in equilibrium. The forces are in balance. That is how it is able to move at a constant velocity. So we need to ask ourselves this question. Is this normal reaction force a vertical force or a horizontal force? So let's go back to my diagram. If I check here, the normal reaction force is a vertical force. So since it's a vertical force going upwards, to keep this in balance, I need a vertical force coming downwards. And that force keeping the object going downwards in balance vertically is going to be my weight. So in this case, the normal reaction force will equal to your weight. So let's substitute. Frictional force is coefficient times, we now know, the weight, because the normal reaction force is equal to the weight. So 0.5 times your weight. We do not have the weight, but we can calculate weight as mass times gravity. Okay, we have the mass, the force of gravity is acting on it. So the frictional force is now going to be 0.5 times, my mass is 85 and my gravity is 9.8. So here the frictional force is 416.5 newtons. So please make sure you remember that the formula to calculate frictional force is the coefficient is the frictional force divided by the normal reaction force. And when the forces are in balance, the normal reaction force going up equals to the weight coming down. We have calculated my frictional force. We should now be able to calculate the force applied that is acting on this object. Okay, in order to calculate the power, again, we said it's the force applied multiplied to velocity. We have the frictional force as 416.5 newtons, which means we should now calculate the force applied. Remember, it is the force applied that is allowing the object to move. That is why in the power formula we are saying applied force times velocity. Accelerating force is applied force minus my frictional force. The accelerating force is calculated as mass times acceleration. My mass is 85, but since the object is moving at a constant velocity and the velocity is not changing, my acceleration here is going to be 0. Force applied is what I'm calculating, and the frictional force is 416.5. Now the reason why we have a minus sign here in this equation is because the applied force and the frictional force are moving in opposite directions. Alright, so since they are opposing the motions and they're moving in opposite directions, it's going to be a minus sign. If you learned about vectors in the section of kinematics, you should also know that the applied force is going east, so it's positive. The frictional force is going west, therefore it is negative. So my applied force is 85 times 0 plus 416.5. How did we get a plus sign now? I took the 416 over onto the other side. It changes from negative to positive. So my applied force is 416.5 newtons. So this is something important that you now need to notice or remember. If we look at the applied force is 416.5 newtons. The force of friction is also 416.5 newtons. So when an object is moving at a constant velocity on a horizontal plane, we should remember that the applied force is equal to the frictional force. Now that we have the applied force, let's calculate the power required. Power required is applied force times velocity. So I'm going to say 416.5 times a constant velocity of 1.8. My applied force is 749.7 newtons. Thank you for watching today's lesson, and if you would like to receive more videos on the section dynamics or the subject engineering science and 4, please subscribe to my channel.